Okay, guys, so welcome to Lecture 9, Engineering 201, Engineering Mechanics 1 at the category University of America, summer section. So let's pray. In the name of the Father, Son, Holy Spirit, and man, direct the Lord, beseech you, our actions by holy inspirations and carried on by your gracious assistance, that every plan and work of ours may begin always from you, and through you come to completion. Through Christ our Lord. Amen. Father, Son, Holy Spirit. Amen. Okay, guys. So I was just saying here for the guys who are watching it online, um, I'm trying a new way to record this screen. So probably you're seeing something different, so forth. So I'm not sure. Um, I know that it's recording, so I can kind of use the computer as well, because the last time these past lectures have been just frozen my computer using the iPad. So let's see. Okay, let's try it. Okay. And today we're going to review the topics that we discuss, we learn during these first 3 weeks, and then we're gonna have our midterm this Tuesday. Okay. So I'm not gonna repeat about the midterm, but you already know it's gonna be online only on Tuesday. Okay, anytime during the day. Please work on homework number 3 as soon as possible. Okay, so I can give you the feedback, and it's a hard deadline, Monday night. Okay, and then Tuesday I will post the solution. So please make sure you review the solution um, before you take the test, just for you to get familiarized with the solution and how it was done um, in homework number 3. Okay, with that in mind, I posed to you a few questions today that we're going to review. I think I have 1, 2, 3, 4, 5, 6, 7, 8 questions. I hope we can go over all of them, and it's pretty much what you can expect on the midterm. Of course, not regarding the amount of questions. Okay, I'm not going to ask you 8 questions. Okay, so from those kind of 8 topics that we have, is not 8 topics. Some of them I just repeat, put more questions. Okay, around these 5, 6 topics, I would choose probably 4 topics to be in the test. Okay, I haven't started preparing the test. I'll do it tomorrow on Friday. Okay, so just keep in mind. But as you know, everything that I have been doing so far is just building up. So if you know one thing here for question 1, you're gonna use this later on in question 5, 6, and you're gonna just build it up. Okay, so please make sure you review everything. All right, so let's start. Question number 1. Okay, if you have any questions, please stop me. I love it, and ask questions or type in the chat. I can see the chat here in my second screen today as well. All right, the pelvis P is connected to a femur F at A using 3 different muscles. Okay, so we have these 3 different muscles, which exerts the force shown on the femur. So we have these 3 muscles, and then we have 80 newtons, 120, and 60 newtons. We want to find the components of the resultant force vector. Okay, the components of the resultant force vector. So I have 3 vectors, 80, 160. Okay, they have their components. 80 here is 30 degrees, 120. The degrees was not given, but it was given like similar triangle that we can find the angle, or we can just go ahead and calculate the sine and cosine. Okay, it's going to be the same thing. So what else? 60 newtons is on top of y. Okay, for those problems, okay, what do we need to do? Okay? And this is kind of the basic from everything that we have been doing, for everything that we have been doing so far. It is components. Okay, components. So let's say that this is F1, let's say this is F2, and let's say this is F3. Okay, with that, F1, F2, F3, let's find their components. Okay. F1, okay, is going to have a component right here, F1 cosine of 30. And it's going to be something here, okay, F1 sine of 30. And I do expect you to, by now, know what is going to be the sine, what is going to be the cosine, okay? As you know, this is the vector, and this is the angle. Okay, the angle is between vector and the x-axis. So this is going to be the cosine. Okay, the angle is touching the vector and x component. This is going to be the cosine, and this is going to be the sine. Okay. What else I need you to think about? Not for this problem because I just put all of them as positive. But what is the direction of each one of those vectors? Okay, in this case, F1 is going to the right, so it's positive. F1 cosine 30 plus F1 sine of 30. And why is plus sine of 30? Because going up. Okay, so these kind of things I want you to master. Okay. Now we have this 120. Okay. Here we have two ways to solve the problem. Okay. One, which is we can get this triangle here, 13, 12, and 5. And we're going to find this angle, pink angle, which is going to be this pink angle right there. Okay, by similar triangles. And we can find that angle by tangent inverse of 12, 5. This is going to be, I'm just make sure here I have everything correct, 6, 7, 38. Okay. And then I know that this one here is going to be F2 cosine of theta. And this one right here, F2 sine of theta. Okay. You can do that. You can use the angle theta. But most of you or some of you go to the books and find it easier, of course, to do the following. If I have this triangle, this angle theta, what is going to be also the sine of theta and cosine of theta? Okay. Sine of theta, SOHCAHTOA, opposite, adjacent, sorry, opposite, hypotenuse, cosine, adjacent, hypotenuse. So we can use the fraction, okay, instead of using the angle, okay, because the sine of theta, which is 67.38, let me just compare here. You're not going to be able to see maybe, but I have 0.92, okay, 0.92. And 12 divided by 13, it's 0.92, okay, so exactly the same thing. Probably you know by now. Okay, so for this one, let me use this one here. I don't think I solved using the fractions before. So what I have here is F2, positive F2, cosine. Cosine is 5 over 13. I plus F2, 12 over 13. J. Okay. Sounds good. F3. F3 is only on top of Y. Okay, it's already on top of Y. So I have no X component. 0 and then 60G. All right. Then what I'm going to do? Well, here I could just sum it, but because I put F1 and not the force, actually, let me change this so I can already sum it. Okay, F1, F2, those are going to be 80, 80, 120, 1 to 8. Great. Now I can just come here, sum. What I'm going to sum? I'm going to sum these I and I's and J's. Okay. At the end, my resultant is going to be, okay. Here I have the solution. So, but let me calculate cosine of 30 plus 120 times 5 divided by 13. This is 115 times 44.44 I. And this is going to be close to 210.77 J. Okay. Okay, let me know if you have any questions. So pretty much this would be, okay, the solution. So those are the components of the resultant vector. I didn't write here, but let me put one more question for you. Okay. What is the magnitude? You can have this question, the homework, of the resultant. What is the magnitude of the resultant? How we find a magnitude of a vector? Okay. If I have this 210.77, 115.44, okay. To agree that the magnitude of FR is going to be what? Square root 115.44 square 77 square. Okay. So this is 240.31 newtons. Okay. So if I ask the magnitude, I mean by I find the components, and then find the magnitude. What about if I ask you what is the angle of this magnet of this the resultant? What's the angle of the resultant? Okay, what not the angle, but the direction of the resultant. So I put it. What are so I can change this. What are the magnitude and direction of the resultant? So this is the magnitude 240.31. Okay, and what's going to be the direction? So here I use theta already. So alpha tangent minus 1 of what? 210.77, 115.44. Okay, these I already calculated. Is going to be 6129 degrees. Okay, so I could have a second question asking you what are the magnitude and direction of the resultant. Okay, and that's how I would solve the second part. Find the components, go to the magnitude and direction. This is working with vectors, just summing vectors together. Okay, this was the first thing that we studied together. All good? Question number 1. Any questions regarding the sum of vectors? Regarding magnitude, regarding direction? Any questions at all? No? Okay. Going to the next problem. Question number 2 today for our review. Okay. This is equilibrium problem of a particle. Okay. Particle equilibrium. Okay. We have all the force, in this case, in the cables, okay, the tension in the cables, acting on the same point, and also the mass, the weight of this box, of this weight. Okay. All right. So starting the problem, two cables are tied together at C. We need to find the tension in each cable. So pretty much what we have here. So let's analyze. Tension AC. Tension BC. Okay. What else we have? Weight of this box. What else we need to figure it out? Okay, my coordinates are here. What is the angle of each one of those tensions, those cables? What is the angle of each one of those cables? Okay, I have the angles right here, 40, but what I need is the angle around here on my orange, so I know what is the direction. Okay, let's use the trig rules that we know, math rules that we know. For example, parallel, and this one also parallel. Once I cut this, what angles are the same? Okay, see if you agree that this angle pink, 40 degrees, okay, is going to be the same as this one, 40 degrees. Once we cut, let's say like this is 40, this is 40, this is 40, and this is 40 degrees. Okay, so my 40 degrees is right there. What about the 30 degrees? Let's say this orange, the orange force. Same, like this, and this. If this is 30 degrees, this is 30 degrees. Okay? Bruno, I don't want to think like that. Okay. Okay, let me give you another option. Take a look at this triangle here. Okay. This is 90, this is 40. How much is this one? 50. Okay. Should be 40 plus this angle should be 90. So plus 90, 180. So this one is 50. Bruno, can I use 50? Yes. Okay. Can I use then 40? Yes. Okay. Whatever you feel comfortable. Bruno, I don't see this 30 there over there. Okay. Do this triangle here 30, 50. How much is this one? 60. Use the 60. Okay. Of course, then the sine cosine is going to change, but sine of 30 is the same as cosine of 60. So at the end, you're going to get the same answer. Okay. So I want to emphasize once again, I really don't care if you choose 30 or 60. Okay. You choose whatever you are able to get comfortable and able to visualize. But at least show me the steps, what are you doing? Okay. And if they are correct, of course, the choice is between 30 or 60. It's not like 30 and 55 and 50. Okay. You have to pick the correct one so I can proceed with the solution. Sounds good? All good? In this case, particularly this case, I will use 30 and 40. Just we use a sine and cosine different. Okay. So you remember that it's not always the same depending on the angle. Okay. Let me just calculate this one here. What we have, 120 times 9.81 is going to be 1177.2 newtons. Okay, 11.77, 1177.2. All right, so starting the problem, TAC. Okay, TAC. Now pay attention. Okay, guys, let's start with the feet on the door. TAC, I have two components. What are those? Two components. Component here and there. Okay. In next, what I have next? TAC, sine of 30. Bruno, why sine of 30? Because 30 here, the angle that I chose, is together with y. Bruno, if I choose 60, then it would be TAC cosine 60. Okay. But what is important as well? What is the direction of that vector? Going to the left. So it's a negative. Negative TAC sine of 30 for my case. Plus positive TAC, of course, plus because going up, plus TAC cosine 30. TB. TB, let's see. The angle is touching the x, so x is going to be cosine, and this x is going to the right. So it's positive TAB cosine 40 I. So if that one's cosine, y is sine, but it's going down. So it's negative TAB sine 40. W is only on y, but it's going down. So this is 0, and this is negative 1177.2. Okay. That sum of the force in x, because this is an equilibrium equation. Sum of the force in x, I have TAC sine of 30 plus TAB cosine of 40. TAB is going to be TAC sine of 30 divided by cosine of 40. Okay. Probably I think this new way to share screen, I have to maybe pay attention to not putting a lot of things in this corner here. Probably my screen's right there. So please let me know if you cannot see, okay? Sum of the force in y. Let's do it. We have space, so let me do it here. So I can also use this part. Sum of the force in y should be 0. So what I have in y is TAC cosine of 30, TAB sine of 40, and 1177.2. Okay, so this is what I have for y. Now, guys, I chose this specifically problem and also to write like this just to show you the following. Okay, please, guys, where I have a lot of mistakes is right here in this space on this step. Okay, I wrote TAB as a function of TAC. So TAC is still TAC, cosine of 30. Now, TAB will change as this one here. Okay, as this one right here. However, please pay attention. TAB here, there is a negative, so I need to keep the negative. Okay, parentheses, TAC sine 30 cosine 40 close parentheses, and then I need to bring what? the sine of 40, okay, equal to 1000. Okay, so this step is where most of the mistakes happen. Please pay attention. If it is negative, bring the negative. And always there is something here, okay? Bring it together, all right? This you can solve by many ways, okay? What I chose to solve here to show you is just solving one by one. Okay, in this case, I solve cosine of 30 is 0.87 TAC. Okay, and then what I'm gonna do is sine of 30 times sine of 40 divided by cosine of 40, and then negative. I should get 0.42 TAC. And then at the end, TAC is going to be that number divided by 0.45. I'll get TAC as 2,616 newtons. Okay, and with that, of course, I'm gonna go back there. I'm gonna write TAB as this. Okay, and I hope I didn't make any mistakes. Okay, so for this one, what I try to do is solve individually and get the numbers just to show you that we can do like that. I think in class, I put them together, cosine and then minus this one here, and solve it once, everything at once. Okay, just to show you you can do like that. Okay, let me 1177.2 45. Yeah, that's it. It's correct. Okay, so this is question number 2. Okay, equilibrium in a particle. Any questions, guys? Any questions? It's all good for those who are here. Okay, going to third question. Third question. Okay, simple one here. For this one, just for us to practice, find moment. Okay. Let's find a moment about A. And I don't know why we have this part here, so let me just delete. Let's consider like up to here. All right. So first thing that we need to do, components of that force. Eighty cosine 25, sine 25. See if you agree. All right. Let's see what's going to cause moment. Sum of the moments. How much is it? Okay. So this is just to find the moment. I'm not saying moment should be 0. This is not equilibrium equation. I'm just saying find the moment. Okay. Find the moment. It's pretty much what we did in homework number 2. Okay. Last week. We just found the moments. Now my question is, let's start here on top then. Is 80 sine of 25 doing any moment about A? No, because its line of action is passing through A. So this, no moment. Is 80 cosine of 25 doing any moment about A? Yes, its line of action is right there. So we have a perpendicular distance of 1.5 plus half, 2 meters. Now my question is, a positive or negative moment? Well, Bruno, I remember that we are considering it counterclockwise is a positive. This one going around A, if I take here point A on the bottom and do like this, okay, is going to be, okay, counterclockwise. So this is plus 80 cosine 25 times 2 meters. All right. What about 70? Is 70 doing moment about A? Yes. Line of action here, we have a perpendicular distance of half. But this moment is a positive or negative? Well, 70 going around A clockwise. Clockwise is negative. Negative 70 times half. What about 30? Is 30 doing any moment? Line of actions right here. I do have a perpendicular distance. It's not passing. I have this 3 meters. Okay. So 330 times 3. Great. And is a positive or negative? Well, 30 going around A clockwise, negative. And that's it. That's my sum of the moment. Here I have 20.01 Newton meters. That's the moment, some of the moments about A. Okay? Any questions? Just straightforward question, okay? Let's calculate moments here. Moments in 2 dimensions. Okay? All good? So again, vectors, some of the factors. Here we have 2D equilibrium in a particle, and then we introduce moment in 2 dimensions, and then here comes the moment in 3 dimensions. Okay, so let's calculate the moment about point O for this case. And we know the tension AB is 1.2, so we have the tension AB force AB. And we know already the magnitude, but we don't know its direction. So we need to use the coordinates. Okay. And again, guys, we are going to choose X, Y, Z. If, probably not, because I just remember it right now. In case I forgot to change the axis to X, Y, and Z, please, you're free to use X, Y, and Z. Okay, change it to X and Y and Z. So we use what we have been using in class. But I'll make sure it's all correct. But just in case, because I mess it up in the homework, I forgot to change. All right. So what do we need to do? First step, coordinates. Coordinates. Points that I may need. Okay? Point. What points I have here? O, 0, 0, 0. Point A. Can I just move this one here a little bit here so I can write everything? Point A, which is Okay, let's go together. Okay, AX is right here. So this is the same plane here, meaning A is 0 in X. In Y is up there, up here. In Y, meaning 2 meters. And B, 0, 2. And not B. And Z is right here. This is the distance, and that distance is, oh, it's not here, it's over there, 1.6. That distance is over there, 1.6. What about B? That's the other one that I'm going to use. O, B, and A, and B. B, and X, right here, all the way there. So this is 1.6 plus 0.8. Okay. So 1.6 plus 0.8 is 2.4. Oh, sorry. This is on Z. My bad. This is X here. This is up to here. My bad. I almost made a mistake. So this is the distance. 1.5. Already calculate Z. 2.4. Okay, so this up to here, that's the distance Z. Okay, that's the distance Z. That's the distance X. Okay, almost made that mistake here. And Y? Y is just on this plane. So 0. Okay. Second step is the F vector. I know it's the magnitude and the lambda. That's going to give us the direction. Okay. So F vector is going to be 1.2 kilonewtons times, is lambda AB, okay? Or lambda AB is B minus A. So B minus A is going to be 1.5 minus 0, 0 minus 2, then 2.4 minus 1.6. Square root of, I know this is going to be 1.5 already, plus I know this is going to be negative 2, and this is going to be, let me put it here already, 0.8. Okay, so I can solve it. This F is going to be 1.2, 1.5, negative 2.8 divided by 2,625. That's what I have my solution. Then I'm put here that this is going to be 0.69I, negative 0.91 J, and positive 0.37 K. Right? Yes. So could increase it. Okay. With that, third step, let me go to this side here, is to find R vector, position vector. And once again, position vector should be from the point to any point of the force, the line of action of the force. Meaning I could go OA, OB. Those 2 points I know. Okay, I don't need to go in the middle of this cable. I could go OA, OB. Which one you should choose? Anyone. Any of those, all good. Okay, just show me what you're choosing. For example, here, OA, meaning A minus O. Okay. And this is going to be 0 minus 0, 2 minus 0, 1.6 minus 0. Okay, this is going to be 0I plus 2J plus 1.6 K. All right. Last step, moment about O is RF. I, J, K, R first, 0, 2, 1.6, F, 9.1, 0.37. Okay? Then you do this determinant by doing what I told you like this, okay? Or hiding this one and doing like this, hiding this one doing like this, hiding, then hiding this one doing like that. Okay. Just remember, if you do like this, okay, when you do the J, it should be negative, and then you open parentheses this one minus that one. Okay. Go here step by step. I'll let you try to do it and find the solution. Okay. When you study, this is my solution. Positive 2.196 positive 1.104 and negative 1.38. Okay. Okay, and this is my solution. So moment about O. Any questions? Any questions, guys? All good? Here, this is question number 4 in case you want to visualize all of it. Okay? All right. So, okay, we are good. We're gonna get it done. All right, this one is a nice problem just for us to practice a few things. Okay? This is regarding equivalent force. Okay, force and couple system. A little bit different from what we did. It is good for you to just do a lot of sum of the force in X, sum of the force in Y, sum of the moments. Okay, sum of the force in X, sum of the force in Y, sum of the moments. Okay, because I want you to find, okay, those are the same beam, 5 meters, okay, and I have 6 scenarios here. And the only thing is you have to find 2 that match, meaning that those 2 systems, they are going to be force and couple equivalent. Okay, meaning let's sum the force in X and Y, and let's sum the moments for each one of those 6, and then let's compare. If the X, Y, and the moments are the same, well, they are equivalent. Okay, that's the thing. Okay, but what is behind this problem is just for you to practice doing sum the force in X, sum the force in Y, and calculate moments. Sum the force in X, sum the force in Y, calculate moments. Okay, so that's the main point for this question. Okay, with that in mind, let me do it. Okay, with you guys. Let me see. Yeah, we'll do all of them here. A. Okay, let's see what we have for A. Take a look here. This is A and B, C. Okay, A. This is on the top. When you do sum of the force in X, what do we have in X? So this vertical moment X, 100 Newton. Going to the right, going to the left, going to the right. So positive 100 Newtons. Okay. Start. Okay. Sum the force in Y. What I have? positive 100. And then what about some of the moments? Bruno, but moments where? Well, now I have to pick. If they are the same beam, same 5 meters, I'll take the moment in every single point. Okay, not the every single point, but the same point in every single beam, in every single scenario. For example, let's take the moment about A. So we're gonna compare the moment about A in every single one. Okay, if that decision is made, it's made. Okay. So some of the force, some of the moments, sorry, about A. Now let's see. Is 100 doing moment about A? No. Is this 100 doing moment about A? No. What is doing moment about A? Well, the 500, that is already a moment. Okay, it's already a moment. If it is already a moment, do we have a distance? No. So this is positive 500 Newton meters. And Bruno, why is 500 positive? Because this is what? Counterclockwise. All good for this first question? Okay. Question B, not question B, but scenario, right? Scenario B. Sum of the force in X. Sum of the force in X should be plus 100 and X3, that's it. Sum of the force in Y. I have negative 100, positive 200. Well, this one I have positive 100 newtons. Okay. Positive 100 newtons, positive 100 newtons. But what about moment? Okay. Moment about A. What I have for moment? Okay. Is 100 Newton here doing moment about A? No. What about this? No. What about the 200? Yes. 200 times 5 meters. This is the same 5 meters. So 200 times 5 meters. Positive or negative? Well, positive. Counterclockwise. Okay. Positive here. So at the end, I have 1,000 Newton meters. Okay. That's my moment. 1,000 Newton meters. C. Let me decrease this a little bit, just because I don't know where is my face around here. I'll figure it out once the class is done and then I see the recording. C. What I have in C is sum of the force in X is 100 positive. Sum of the force in Y negative 500 positive 400 negative 100 newtons. Now it's negative 100 newtons. What about the moment about A? Moment about A. 500 newtons? No. 1800? Yes. Clockwise? Negative. So this is negative 1800. 100? No. 400? Yes. Positive times 5. This is going to be 2000. 2000 minus 1800. Positive 200 Newton meters. So far, so good? D? Sum the force in X. Positive 100, and that's it. Sum the force in Y. Negative 100, negative, oh, sorry. Positive 100, start from here. Positive 200, and negative 400. This is negative 100 newtons. Moments. Some of the moments about A. Those two 100, no moment. And then I have 200 times 2.5, positive. Positive 17,000. I'll write a moment. And negative 400 times 5. How much is this? So this is negative 200, positive 17, so it's going to be negative 300, and then this is going to be 500, negative 200, positive 200. Okay? E, C, components. This one, once again, this one you can just save some time. If this is 3, 4, 5 triangle, okay, 3, 4, 5 triangle, and this is 500, well, in this case, this one here is 300, this one 400. Okay, so we keep the 3, 4, and 3, 4, 5, but in the hundreds. Okay, 300, 400, 500. Okay, same ratio. So E here is going to be the following. Sum the force in X should be, not should be 0, but should be how much? I have positive 400 going to the right and negative 300 going to the left. That's it. So I have positive 100. Sum the force in Y should be positive 300 and negative 200. So I have positive 100. Moment, sum the moments about A, okay? 300 no, this 400 no, these other 300 no, okay, no, no, no. Of course, it's no, all of them no. 1200 counterclockwise, so positive, and then negative 200 times 5. This is going to be 1,000, then it's going to be positive 200 Newton meters. And the last one, F, sum the force in X. This one, I don't have any X, so 0. Sum the force in Y, positive 100. And some of the moments about A is counterclockwise 300, positive. Counterclockwise 100 times 2.5. 2.5. And clockwise negative 200. Okay. At the end, this is going to be 2.5, 250, 550, 350 Newton meters. Okay, whew. A lot of them. Okay, so what we need to do is just compare 100, 100, 500. I don't have any 500 here. I know I have a lot of 100. This is not 1,000 as well. I don't have any 1,000. 200, I have this one, this one, this one. So those three. And then 350, I don't have anyone. Okay, comparing X 100, 100, 100, all good. And comparing Y, negative, negative, positive. This go away. Okay, my solution would be, okay, C and D, they are the equivalent systems. Okay, they are equivalent. Okay, so a lot of repetition, but just for you to get practice on moments, especially moments. Okay, especially moments. What time is it? Okay. Any questions, guys? Any questions? Any questions? No? All right, now we go to our last topic. Okay? Our last topic is the equilibrium on rigid body. Two dimension, okay? Equilibrium on rigid bodies. Okay? And because this is just what we covered this week, so I brought 3 problems, okay, just for us to practice more and more, and for you to help you on the homework, okay? And to tell you the truth, I think this equilibrium rigid body is the most important topic, okay, so far, okay, because put everything together, okay? So we have, as I cover up to now, we have 6 topics. Probably I'll merge a few of them or choose 4 topics and think about 4 questions for your exam, okay? But if I have to tell you one thing, of course, for sure, equilibrium in a rigid body is going to be there, okay? So 6, 7, and 8, here are the questions. Something related to them is going to be in the test, meaning what we are covering this week. Sounds good? Any questions? No? So let's start. Question number 6. Calculate force and moment reactions at the voltage base O. At the voltage base O. Okay, I already know that we have force and moment reactions here. Okay, so probably this is a fixed support. Okay, same as saying a fixed support. Each traffic signal has a mass of 36 kilograms, and the mass of members OC and AC are 50 kilograms and 55 kilograms. For then the mass center of AC is at G. Okay, sounds good. Okay, starting here, the problem, what are we going to have? This weight right here, which is going to be the same as this one here. We also have the weight of member AC at G. So right here, weight AC. Okay. And we're going to have the weight of the member OC. Now guys, member OC, they didn't say anything where we're going to put this member. Well, the weight is going to be right in the middle. Okay. Now this is kind of maybe tricky. Okay. And where should be the direction of this, the weight? Okay. So the direction is always pointing to the ground. Okay, to the center of the earth, gravity. Okay. So this is the weight OC. All right. Let's already calculate this. What is weight? Okay. So because of space, I'm gonna save. I'm not gonna draw the free body diagram. Okay. So I mean just draw all of here. So this is gonna be 36 times 9.81. Okay. Don't forget, kilograms is not a vector. Mass is not a vector. Okay. What is going to be the vector and what we need is the weight. Okay, the weight. This is here my calculation. I have here 353.16 newtons. Same for this second one, okay? So I'm not gonna write here, but it's the same. AC is 55 times 981, which is going to be 539.55. And for this one here is 50 times 9.81, which is going to be 490.5 newtons. Okay? And then, already mentioned, OY, OX, MO. Okay? All good? All right. So sum of the force in X should be 0, OX 0. Okay? So we don't have a reaction on X, okay? Because we don't have any other force here in our system in the X direction. Sum of the force in Y, negative 353.16. Don't forget, it's twice. So negative 353.16. Negative 539.55. Negative 490.5. Positive OY 0. So OY is going to be all of these. And actually, I don't have this answer here in my notes. So let me calculate this times 2, then 539.55 plus 490.5. So this is 1,736.37 newtons. All right. Sum of the force in Z equal to 0. Oh, Z. What I'm thinking about. Some of the moments about O is not 3D anymore. Some of the moments about O. So what I have for moments about O. Okay, so let's pay attention now. Is W doing any moments about O? This first W? It is. Okay, and what is the perpendicular distance line of action to that point? Okay, you agree that this, all of this, 5, 1, 4, so 10. So I have 353, 16 times 10. Positive or negative? Positive, counterclockwise. So if that is positive, this also is going to be positive. But the distance now is 5. 353, 5. What about WAC? WAC is also positive, but the distance is 4. Positive, 539, 55, 4. What about WOC? No. WOC, the weight here is passing through O. So I don't have moment regarding WOC. Okay, guys? So this is passing through O. Line of action top of O. Okay? And my last one, this reaction. And here I chose to write clockwise, meaning negative MO equal to 0. So MO is going to be, okay, that one, 353.16 times 10 plus 353.16 times 5 plus 539.55 times 4. 7,450 0.6 Newton meters. That's my moment. Oh. Any questions? Any questions here in the chat or anyone else? Okay, let's keep going. Okay, all of these. Another question here for equilibrium. All right. The homogeneous 120 kilograms wooden beam that's suspended from ropes at A and B. We have a power wrench applies a 500 Newton meters clockwise couple to tighten a bolt. Determine the tension in the ropes. All right. Okay. So similar one. Chose this one just to show you about the couple moment here that we have. Okay. So right here, I have a tension A. Right here, we have tension B. Keep in mind that always read the statement. Even though it's not showing anything here, what is saying? 120 kilograms wooden beam. Guys, if I give you, or if the problem is giving you the mass, you have to consider the weight. Okay? If I didn't mention anything, then you just start the problem right now. However, we have the weight. And where is going to be the weight? But the weight, if this is 4 plus 2, 6, the weight should be something here. Okay? Right in the middle. At the center of this beam. Okay, guys? So please pay attention. Please pay attention on it. Okay? Let me, I think this is just straightforward and then I have some space. So let me draw the free body diagram here. Free body diagram right here just for you. Would you visualize? Right here I have TA. Right there I have TB. Right here somewhere I have W, which is 120 times 9.81. I'm going to calculate the moment. And right here I have the couple, which is 500 Newton meters. Okay, all of this is 4 meters, this is 2 meters, and this is 3 meters. Okay, this is 120. I think something was already 120, 1177.2 newtons. Okay, now I can solve the problem. Okay, this I didn't mention anything in X. Okay, because those cables just the beam can move. Okay, the cables are just putting Y reaction over there, but I don't have anything in X, so I don't need to start in X. I'll start in Y. Sum of the force in Y should be 0. So what we have is TA going up plus TB going up minus W going down. So I know that TA plus TB should be 1177.2. And then what I'm going to do is the moment about A. Moment about A, TA, no moment. Okay. W, moment times 3, okay, that's the distance, negative, so negative 1177.2 times 3. TB is going to be positive counterclockwise times 4. TB times 4. And then 500. 500 is already clockwise and is already a moment. So it's already negative, okay, negative 500. No distance because it's already a moment. Okay. By doing that, okay, it'll let you to figure it out, the calculation. Got 1007.9. Then for CA, 169.3 newtons. All right. Any questions? Questions, guys? If not, let's go to the last problem. And this is really like this problem. Whoa. Few things for you to think about. Okay? All right. Last problem here for our review. And then I will stop recording after this problem number 8. And then guys, which are here online live, if you have any questions regarding homeworks, regarding the problems that we did in class, please stay here after I stop the recording, and then we can discuss a little bit more off the cameras. All right. So let's go for this last problem. Let's see what's going on here. Okay, I really like this problem because I have a few different things from what we are used to do. So let's see. The table lamp consists of 2 uniform arms, each weighing 0.6 pounds. Okay, so this is the first information. Arms, 2 arms. Each one of them 0.6 pounds. 0.6 pounds. They are the same, 20 inches, 20 inches. Okay. Keep this information. They have weight. And I already give the weight of this bulb fixture, so it's going to be 1.8. Okay. And it's saying the following. If this arm here, okay, if this arm is inclined, okay, 15 degrees, calculate the couple CA that must be applied by friction in joint A. Okay, joint A. So what is saying? It's saying that we have this system, we have the weight. Okay, we're gonna calculate here the weight, blah blah, the weight of this object. But as you can see here, this is a pin connection. Okay, I don't know if you have right here. I don't have my table this kind of this lamp, but you can rotate, right? You can rotate. So this pin connection is just giving you, okay, it's just giving you AY, and I can write here AX. Okay, that's truly a pin connection. And asking you to find what should be the couple CA that must be supplied by the friction. So you already have a lamp like this. Okay, you rotate it and it's going to stop. And why is it stopping? Why is it freeze in that position? Because we have friction. And that friction will restrict the rotation, will not allow this to rotate. Okay? Not allow it to rotate. Okay? So here, what is asking is the following. What should be the couple moment CA, or let me change the color. Let me change the color to color, I don't know, this one here. Because CA is not due to the pin, okay? Essentially, it's not a pin restriction. It's because of the friction, okay? So we have the reaction, support reactions, AX and Y, and also we have friction in this case, okay? And the friction is not allowing us to rotate. So how much should be this couple by the friction, okay? This couple by the friction, okay? That's what we want to find. So pretty much what should be this external force, okay? This external force by the friction that will allow us to freeze, okay, this lamp like this in 15 degrees. So that's our goal here, all right? To that, what are the force acting on my problem? Well, I don't have any other external force other than the self-weight, the weight of the object, okay? It didn't say the guy is applying force here, there, blah, blah, blah. No, just say like that, okay? What should be the friction, the couple, okay? So just the weight. So if we have just the weight, let's include the weight here. Let's include the weight. Now, let's start with the bulb, okay? Very clear here, right in the middle of it, we have WB. Can I call it WB? We already know it's 1.8. Okay, I'm gonna put this in a free body diagram in a moment. Now let's think about the arms. Okay, the arms. They weigh 0.6 pounds. And where should I be applied? Okay, let's see the first one. Where should be applied the weight for this one? Well, where is the point G? Right, the center. Okay, uniform, kind of common shape. Right at the center here should be WA, W of the arm. Okay, arm weight. All right, for the first one. How about the second one? For the second one, exactly the same thing. The point G is right at the center. Okay, the center is right here. Okay. And how should be the weight? The weight vector we just discussed. Okay, for the problem number 6, should go down like this. Weight A. Okay, so it's offset. There is an offset between the weight A and AY. Okay, this is going to be important. So those kind of things I want you to. So that's the problem 8, just putting together a lot of different things. So that's why I'm so excited for this problem. So good. Okay, for you to think in different ways. All right. So let me show the free body diagram. Free body diagram. So let's figure it out a few things here before we start calculating. Okay. Let's take a look. Right here, so I have 4 inches. Let's see how I'll do it. 4 inches of the bulb. And then I have 20 inches. Say up to here, something like that. So right here is my bulb, and then I have the 20 inches. Okay, so here I have 4 inches. Let me put it like this. Save some space. 4 inches. And this 4 inches I have right here. WB that was already given. How much WB? 1.8. So let me put the numbers here, pounds. Okay. Now I have this, between these 20 inches, I have WA, the first one. It's right in the middle. So if you agree with me, right here, I have 0.6 pounds. What is this? This is 10 inches and 10 inches. All right. And then we have 15 degrees, something like, I don't know if it's 20 inches, like this, by now. Okay. Okay. Right here, let me put out right here once again. We have AY. We have A x. And also that's what we want to find, the CA. And let me just change here, arm. To not get confused with point A. Okay. And then we have right here in the middle, somewhere here, we have this 0.6 pounds. 0.6 pounds. And I think that's it. Okay, the force are there. Okay. And if you agree, if this is at a half, this is 10 inches, this is also 10 inches. Okay, the inclined distance. Now, guys, this right here is 15 degrees. So you agree that this angle here, theta, is going to be the same as, okay, same as this angle here. Okay, so let me delete this one here, this 10. And put this. Okay, exactly the same thing. Okay. The 10 inches. Okay. 15 degrees. So let's start trying to solve it. And then we're going to figure out a few things. Okay. If we stop here right now and start solving, sum of the force in x should be 0. Well, AX should be 0. Sum of the force in y should be 0. Then 1.8 negative, negative 0.6, negative 0.6, positive AY should be 0. So what we have, AY equal to, how much is it? 1.8 plus 0.6. Oh, 3. Yeah, 1.2. 3 pounds. Okay. Now let's go for the moment. Let's figure out the moments before we jump there and do something else. Moment about A. What do we have about A? Now pay attention, guys. Pay attention. Is 1.8 doing moment about A? Yes. Okay. Yes. Line of action is not passing through a point. But then what is this distance to point A? What is the distance 1.8 to point A? Even though I couldn't hear you, someone watching this live answered me 24, which is not, okay? Which is not 24. Okay, it's not 24, because 24 is the distance from here to that point. But the point A is in this point here, this direction? No. Point A is right here. It's right here. Take a look. Somewhere here. That's the distance. How much is that distance? I don't know. What should I do? You should find. You should find that distance. Okay? How can I find that distance, Bruno? Then use your engineering knowledge, your engineering thinking. Okay? How can you find that distance? Okay, you need to find this distance here. Okay? That distance. Okay? This is the line of action. Should be this two. There. This is distance. D for the bead bulb. What is this distance? It's not 24. It's 24 is all of these up to here. Oh, let me take a look. Bruno, what about if I found this distance? Can I remove from 24? Oh, that's a good idea. Okay. Or if you want to work with this triangle here, it doesn't matter. Work this with that. Okay. You can find this distance up to here and then remove. So let's do that. Let's do that. So let me bring this triangle here. Let's see if you can see it. I'm gonna use this one here. Okay. I'm bringing, oh, sorry. I'm bringing this triangle here. Hope you can see this triangle to here. How much is this one? 20. Oh, sorry. This one here is 20 inches. 20 inches. I have the angle 15 degrees. The angle is 15 degrees. So if I want to find what is this? Let's call x, okay? X, sine, cosine, tangent, tenus, SOHCAHTOA, SOHCAHTOA. Sine is opposite. Oh, sine of angle. Opposite. Well, I have the opposite. Tenus. Okay. So x is going to be 20 sine of 15 degrees. 20 sine 15 degrees, 5.18 inches. 5.18. So now I know that this one here, which color didn't use yet? Well, I use a lot of colors already. So let me put with blue again. I know that this distance here, up here, from this one here, okay, this distance to here is 5 point, what I said? 18. Cannot see, let me put it here. 5.18, that's the distance. Inches. And how much is going to be dB? Well, dB in this case is going to be 24 minus 5.18. Okay. Can we write this on the moment equation just for us to keep organized? This is going to be counterclockwise, so it's going to be positive 1.8 times. And put it here, 24 negative minus 5.18. And put it there just to keep organized so you can see. Then we have positive 0.6, and the distance is not 10, is 10 minus 5.18. Again, of course, you can do this calculation outside and come here, just put 18.82. That's the answer here, 18.82. Just putting here for you to visualize what we are doing. Okay? So we have those two. Now my question for you, the next one, the 0.6, guys. 0.6. Use your math knowledge. How is the distance? How much is the distance? First of all, it is clockwise, so it's negative 0.6 times something. What is this something? Bruno, it's 518. No, it is not. 518 is right here. And my 0.6 is right there. So it's this distance here. How much should be this distance? Where does apply? This apply at the center of these 20 inches. So that's why we split 10 and 10. Well, similar triangles. If this is 20 and this is 518, how much is this going to be if this is 10? Half of it. Half of it, guys. 518 divided by 2. And then lastly, negative CA in my case here. And all of this should be equal to 0. Okay, so CA, let me do this calculation for you. CA is going to be 24 minus 518, this plus times 1.8, 33.876 plus 10 minus 518 times 0.6, 2.892. And the next one is negative 518 divided by 2 times 0.6, 1.554. CA is 33.876 plus 2.87 or 892 minus this one there, 35.214. What is this? Pounds inch. And that's my answer. That's the answer. That's how much should be the moment applied by the friction. Supplied by the friction. Any questions? All good? Okay, so before I stop recording, please, guys, watching it later, if you have any questions, email me, okay? Email me, whatever you're watching it, okay? During the weekend, it's kind of hard for me to reply to you. Probably I will reply late at night, something like that. On Monday, I'll be traveling, okay? So if you um, send me an email and I didn't reply to you on the weekend, I will reply on Monday in the airport, okay? For sure. All right. On Monday, also, probably I can meet you or can go over a few things probably in the evening, okay? Once I'm set. So, in case you need. Other than that, Tuesday, okay, we're not gonna have the class. We're not gonna meet here Tuesday. Okay, it's an open day for you to take the exam. Okay, so don't expect me on Zoom. You can take it anytime. Okay, if you have any other questions, then please let me know. Okay, and then we can arrange something. But please don't expect me on Zoom 10:45 on Tuesday. All right. So as I said, I'll be traveling. So next week, I think I will try my best to record the class. And the other day, the class is canceled because I'll be coming back home. All right. So let's communicate through email and get things done. All right. All good. So let me stop recording. I'll see you next week for the test. And I hope you have a great weekend. Study for the test, please. Okay, come prepare and do your best. All right, so see you.